We saw before that the derivative from the graph of sine looked like it was going to give us the cosine function. Now we're actually going to do this using the definition of the derivative and see if we get the same result. So we've got f of x is equal to sine of x. Then f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x, all divided by h, which in this case is equal to, maybe I'll come down here, the limit as h goes to 0. I'm putting in x plus h everywhere that I see an x up here, so that's sine of x plus h. And then f of x is just sine x, all divided by h. And there's really not a lot I can do with this unless I remember that double angle formula that I gave you up here. So this is why I gave you that formula, is because we're actually going to use it here. So according to the double angle formula, sine of x plus h is equal to the sine of x cosine of h plus cosine of x times the sine of h, of course, minus sine of x off to the side. That's all divided by h. And I'm going to actually split this up into two different pieces. So I'm going to start by looking at the this cosine x times sine h over h. Sine of h over h. And then I'm going to do a separate limit where I take the sine x cosine h minus sine x over h. Sine x cosine h minus sine x over h. And it will become clear in a moment how I knew to do that. And I'm going to do one last step here. This is a little bit tricky. This limit is as h goes to 0. We've also got the variable x in here. But in terms of the limit, the h is the only thing that's changing. It's the only variable. This x has no bearing on the h, so I can bring the cosine x out in front and just look at the limit as h goes to 0 of sine h over h. Similarly, I can factor a sine x out of both of these and calculate the limit as h goes to 0 of cosine h minus 1 divided by h. So what we're going to do, and I'm going to call this, remember this is my f prime of x, and I'm going to call this spot right here star star. I'm going to refer back to it. And the way I'm going to figure this out is I'm going to figure out this limit right here, I'm going to figure out that limit right there, and that's going to tell me what my result is. So I need to figure out the limit as h goes to 0 of sine of h over h. If I plug in h equals 0, I just get 0 over 0, which is indeterminate, which tells me nothing. So I need to do something else. And normally I would factor or rationalize or combine fractions, but I can't do any of that here. Nothing really works. So what I actually have to use is the squeeze theorem. And I'm not going to go into the details here. I might make another video to show this in more detail. But you can actually prove, and they do this in the textbook, they show that cosine of h is always less than or equal to sine of h over h, which is always less than or equal to 1. And this is true whenever you're near h equals 0. So in this area, close to the limit here, we happen to have this property. And then, of course, I could take the limit as h goes to 0 of all three of these things. And what do I get? Well, here I can actually just plug in 0. Cosine of 0 is 1. This limit as h goes to 0 of sine of h over h is exactly what we're trying to calculate. And then the limit as h goes to 0 of 1 is also just 1. So this limit gets squeezed in between 1 and 1. So this implies that the limit as h goes to 0 of sine of h over h is equal to 1. And you could also check this if you don't believe the squeeze theorem by plugging in some small values of h, like h equals 0.01, and then you divide that by 0.01. You'll be getting a value pretty close to 1. Okay, so we now know that this is equal to 1. What's that thing right there? Well, to do that, we've got to do another calculation. Let's do that up here. The limit as h goes to 0 of cosine of h minus 1 divided by h. Well, again, if I plug in 0, cosine of 0 is 1. 1 minus 1 is 0, divided by 0. That's indeterminate. It's useless. But to solve this one, I can actually do a trick along the lines of rationalizing. I've got a cosine of h minus 1. I'm going to multiply top and bottom by cosine of h plus 1. When I multiply that times that, I get cosine squared h. My middle terms, my outer terms cancel, cosine squared h minus 1, divided by h times cosine of h plus 1. And cosine squared of h minus 1, according to this rule right up here, if I subtract the 1 to this side and I subtract the sine squared to the other side, this will actually be equal to a negative sine squared h divided by h times cosine of h plus 1. And I can split this into two limits. This is the limit as h goes to 0 of sine of h over h times the limit as h goes to 0 of sine of h, negative sine h over cosine of h plus 1. Now this limit right here, we just calculated. It's equal to 1. And this limit right here, you can actually plug in 0. You get negative 0 on top, and on the bottom, you get 2. Of course, 0 over 2 is just 0. 1 times 0 just gives you 0. Okay, so now we're basically off the page. But let's come back to star star. This thing right here. We get f prime of x is equal to cosine x times this limit, which we found to be 1. So that's cosine of x times 1, plus sine of x times this limit, which we just found to be 0. That dies off, and we just get f prime of x equals cosine x, which was what we were expecting, because that's what we saw from the graph. So the derivative of sine x equals cosine x, and the derivative of cosine x, we can do a similar kind of calculation up there to show that this is equal to negative sine x.